Hello, I'm Danny Wijns. I will present here today the first results of a large-scale survey that we are running on the use of self-adaptation in industry. As you can see here on the slide, there is a whole team involved in this effort from different research groups all over the world. Let me start with the motivation for the survey. Yes, we as a research community, we are doing research on self-adaptation for quite some time, since the 2000s, in fact, already before, but let's say we talk since about 2000 of self-adaptive systems. And in this period, we have built a lot of knowledge about the self-adaptation and how to engineer the systems. Now, if you look at industry, in fact, the initial efforts on self-adaptation were not only efforts from academics, but also from industry. For instance, IBM started with their famous autonomic computing initiative, also in the early 2000 years. And we are all aware of well-known examples of self-adaptation in industry. Probably the most well-known example is elastic cloud. However, if you look at the reported efforts, there are only a few joint efforts between academics and industry. So to some extent, these two worlds, let's say, they have developed a bit independently, or at least not closely connected. So as a result, since we as researchers, we document our efforts in papers and in books, you name it, but people in industry do this less. So at this moment, it is not clear what is the state of the practice on the use of self-adaptation in industry. And obviously, it's important for us as researchers to know what is going on in the world and what are the issues there. And on the other hand, it might also be beneficial for industry to know what the current practice and the issues are with self-adaptation in industry. So the objective of our survey was to obtain an insight in the state of the practice. And to that extent, for that reason, we launched a survey, a large-scale survey. And the motivations of this study are, the objective, for this study was to understand the motivations why people in industry apply self-adaptation, for what type of problems they apply self-adaptation, and how do they tackle these problems? How do they realize self-adaptation? Are they facing any risks? And if so, what types of mitigations do they apply? Do they face any challenges? Do they see any opportunities, probably beyond what they do, and probably in collaboration with researchers if necessary? So we were interested in all these different aspects. Now, in this paper, as I said, we are reporting only the initial results, and we focus here on three aspects. And so what motivates practitioners to apply self-adaptation is the first research question. The second then is what kind of concrete examples are there? How do people in industry apply self-adaptation in terms of use cases? And then third, what difficulties do they face when they apply self-adaptation? And it gives us a first kind of small insight in the different aspects, in different key aspects of the use of self-adaptation in industry. So we use the population active practitioners that have sufficient expertise and preferable over a wide variety of domains that are representative for current practice on software engineering in industry. We actually approached these practitioners in two batches. The first, we sent invitations to 203 practitioners, the second time 134. This survey that I report here today is based on these 203. So the survey contained about 30 questions. They were all predefined questions. Some were closed. I mean, we had options to select, and others were open where they could write text. And obviously, all these questions, they cover the different elements that I was mentioning before. You see them listed here. So we expected that the effort would take about 25 minutes. So I balanced a bit using closed and open questions to get sufficient amount of data without asking people to work too long on it, because it would probably, we would have less data because people would consider it too much of an effort. In fact, based on a pilot, we measured that it was 24 minutes on average. And then for the analysis of the data, we used simple frequency analysis for the closed questions, and we did coding for the open questions. And for those of you who are familiar, coding of open questions, it submit many answers is a highly complex and labor-intensive effort. So let me report now the results here. The first batch of these 203 invitations, we got 113 valid answers, and of those, 62 of the participants applied self-adaptation, meaning that we got like 56% of the people that answered they apply self-adaptation, which is a high number. And well, we were surprised to see that high number. And if you look at the top types of systems that were built by these organizations, you see here the list. So web and mobile systems were the highest number of types of systems. And the middle column shows the number for all the participants, and the right column shows those that apply self-adaptation. Second is embedded, cyber physical and IoT, which is also very prominent, and then other types, transportation networks, etc. So there were a whole bunch of types of systems. Basically, you can say most of the types of systems that we can think about today where software engineers are active or represented. And you can see that basically the percentages of those of all the participants and those that apply self-adaptation are very similar. And so basically most types of systems are also used in terms of use of self-adaptation. If we look at the organizations, the size of the organizations, about half of them were sized with over 100, and the other half were between 1 and 100. And you can see that we got a whole variety of organizations. Here again, those that apply self-adaptation, the percentages of the different classes are very similar to all. So in fact, we see that self-adaptation is applied by all types of organizations. If we look at the concrete participants, we asked them for their role, and you see that about 50% of the people were the role as project manager or coordinator. Note that 3 on 4 give one role, but the other 25% give several roles. So not surprisingly, many are programmer and architect or designers. And then you get the other typical roles that people have in organizations. And if you look at their experience, the experience there is on average something between 9 and 20 years of experience, meaning that the people that participated in this survey have a very different roles. All roles are more or less representative, and they have substantial experience. And only 8% were on between 1 and 3 years of experience. If we look at the motivations why people apply self-adaptation in industry, the results are not so extremely surprising, I would say. You see that the highest number is to optimize performance. Then obviously people apply self-adaptation to automate things that otherwise were done by operators, and to reconfigure or configure a system or reconfigure it dynamically during runtime. And that can be to deal with changes in the environment, to detect and resolve errors, so self-healing. Also, a significant number of people, 40%, reported that they detect and protect systems against threats. And a few answered that they also deal with changing business goals. On average, I remember we had something like 3.4, I think, problems that people on average consider as interesting to apply self-adaptation. And if we look at the key benefits, actually we could identify 4 different categories of benefits. On the one hand, not surprisingly, it is One of the key aspects why people apply self-adaptation is to improve the utility of a system. And you see that in particular, robustness and performance are high scoring. We only give here the top answers. The details can be found in the paper. Also for industry, savings in terms of cost, financial costs and resources are of high importance in terms of the benefits. Also, industry people highlight that the improved user experience of the systems is a key factor in terms of benefits, and of course also a reduced burden on engineers, in particular operators, is an important benefit. And lastly, also the handling of dynamics is considered as automatic handling of dynamics, in fact, is considered as a key benefit. So instead of having humans to deal with context dynamics or load dynamics, now the system can handle it itself. Maybe the most important question that we asked was, give us an example of a concrete self-adaptive system you have worked with. And then people wrote their text, often a few lines, sometimes even 10 lines of text where they explained. Most of the people did that, like I think close to 100% of the people that applied self-adaptation provided us such an answer. And I give here a few short excerpts of the answers that we got, but we see here also 3 categories in terms of their answers. So we coded a text and we identified 3 categories of interesting information. So one is the subject of adaptation. So what is actually adapted? And you can see that 16 of the participants said that the system was adapted. Like there is an auto-tuning of a whole machine there that is producing energy. Or it can be a module, a particular element that is part of their server park. Or it can be a support system, for instance, a virtual machine that is automatically adapting, tuning the performance of a program that it executes. So in all, you can see that adaptation is applied at any type of level of a system, the whole system up to small parts of the system. Then we also could identify the types of adaptation that people apply, and their auto-scaling is really the top answer in industry. For instance, a cluster that is auto-scaled to deal with resources, to optimize the resources that they require for the quality of service that is needed. Auto-reconfiguration is another important thing, automatic reconfiguration of a system to achieve the goals that they want to achieve with their self-adaptation. Here, for instance, in the example, safety and availability. And auto-tuning, where as an example here, for instance, a feeding robot that adjusts the food amount automatically based on some parameters. For instance, I remember food waste in the past was one of the elements that robot took into account to adjust the amount of food that it was providing to some person. And lastly, another category we could identify in the descriptions of these use cases were the trigger for adaptation. And you see there that there are different types of triggers. The key triggers were load of the system and events that happened, for instance, incoming data, events of data. And then besides that, properties both in the environment and the system. So we see here certain things appearing that we as resources recognize, but sometimes the balance between things is not automatically what we would consider as key in the types of systems that we consider in our research. An important part was also the difficulties that we were probing to see what kind of issues people face with self-adaptation. And actually, a lot of people reported difficulties. I think 7 on 10 reported that they have difficulties with implementing self-adaptation. Among those where we found different categories again, life cycle issues. So basically difficulties cross-cut the whole life cycle. Tuning and debugging was one important element where they face issues, how to debug these kind of self-adaptive systems. They were also reporting limitations in terms of the tools they have and the methods they use. I recall that people were, for instance, complaining about the fact that not always the right metrics were available in the tools to measure what they needed to measure to realize the adaptation. They also listed several design challenges. One particular was how to ensure a reliable design that is trustworthy, in particular given the complexity of such designs. I also mentioned here security, and you see the number of occurrences is only one. I highlighted here, which shows that people in these answers are not considering security as a big issue in terms of the challenges they face with respect to the realization of self-adaptation. They also highlight issues with people and processes, and in particular, the fact that you need skilled people that can deal with the technologies that they need was an issue that was sometimes problematic. And lastly, they also refer to runtime challenges. And there you see a runtime uncertainty popping up, and also the collection of data, which is in a distributed setting, realistic systems, not always an easy thing to do. So they raise it as an important challenge. So let me now summarize a bit with the key insights that we get here from this survey. So about half of the participants that responded to our survey apply self-adaptation. As I said, this is surprisingly high, I would say. What we see is that practitioners, they apply self-adaptation for very similar things as that we do as investigators in our research. However, practitioners, they do not put any emphasis on uncertainties, which is now the last, let's say, 5 to 10 years, really the key focus in research. So there is really a kind of discrepancy here in terms of what people in industry and research consider as the main focus of self-adaptation, something to investigate further, probably. We have seen that self-adaptation is applied at different levels of the software system, going from complete systems to small parts. And in fact, the dominating types of uncertainties are auto-scaling and auto-tuning and automatic reconfigurations. And in fact, I have not highlighted here, but in the different illustrations, you can see that in the paper, you will see that elastic cloud and container orchestration-based support is, in fact, these are the key enablers for realizing self-adaptation in practice. We have seen that a lot of people in industry face issues when they apply self-adaptation, and these issues, they cross-cut the whole life cycle. And they refer to the design, the testing, runtime, and even evolution. And also important is saying that besides these technical challenges, also the need for skilled and experienced people is often reported in the survey. So let me conclude with highlighting a few issues for further work that we are doing. In fact, it's an ongoing effort, and we just finalized the second round of data collection. Now, while the initial focus was on Europe, we focus now on other areas in the world to better balance the data and get a more representative picture of the whole globe, at least a significant part of the globe. For the second round, we got 66 valid responses from 134 invitations, and again, around 55 of them apply self-adaptation. This means that we have now in total of the 337 invitations, like 98 responses for people that apply self-adaptation. Our target was 100, so we're very close to our really ultimate goal that we want to achieve. So we have a lot of data, and that we are currently processing, and it will, believe me, still take a lot of time to process all the data we got. So we are looking now not only in what I told here today, but also looking at how do practitioners apply self-adaptation, how do they ensure trustworthiness, and what risks do they face and how do they mitigate that. We also probed what type of opportunities they see within their own practice, but also beyond that for applying self-adaptation. So what is the vision of industry, in fact, in terms of the future for self-adaptation? And we also explicitly asked them whether they see any collaborations with researchers to help them with applying self-adaptation and for what particular types of problems that they want this kind of support. And besides this survey, this large-scale survey, we're also running a series of interviews with practitioners, both those that apply self-adaptation and those that don't apply self-adaptation, to get more in-depth insights in the state of the practice. So that brings me to the end of this talk. If you are more interested, please have a look at our paper, or you can also have a look there at the link that you see there at the bottom, where you can find all the information. Thank you very much.